Hello, third graders. I hope you had a wonderful weekend and you're ready to get back to learning some mathematics today. So let's go ahead and take a look at our DMA for today. We are going to take a look at our first problem, which is a time problem. And this is called elapsed time. Elapsed means time that has passed. So again, elapsed means time that has passed or gone by. So we are on week 31. If you notice, we're on week 31, day 1. It's Monday. So let's take a look at this elapsed time problem. It says Victor is going on a trip at 3:15. So that means this is the time he is going to leave. He needs 30 minutes to pack. What time does Victor need to start packing so that he will be ready to leave at 3:15? So we have what's called an end time. An end time is a time where we need to be ready, or the time that is at the end of the elapsed time. So our end time is at 3:15. We need to go back in time and figure out what our start time is. So I'm going to use what's called an open number line to help me count back 30 minutes. Now, I can do this in a couple of different ways. I can go back by 5s from the 15, or I could go back by 10s. So we could do either one, but it might be easier for you to go back by 5s. So let's count back by 5s. So one group of 5 is going to be 3:10, and then back again by 5 would be 3:05, and then let's count back another 5, which would be 3 o'clock. So now we're at 3 o'clock. So we've gone back, 15 minutes so far. So we've subtracted 15 minutes from the 3:15. Now we need to go back another 15 minutes to make this 30. So we go back 5, which would be 2:55 because we're going back over the hour. Another 5 would be, 2:50. And another 5 would go back, another 5, which would be 2:45. And this would be the time that he would need to start packing. Now, another way to look at this is if you were to use a clock, and I'm just going to use my little Judy clock here. The time is 3:15 right now. And so I'm going to do the same thing that I did, except now I'm just going to use my Judy clock and I'm going to go back by 5s. So 3:15, go back 5. Now we're at 3:10. Go back 5. That's another 5, so we've gone back 5, 10, we're at 3:05. Go back another 5, that's 5, 10, 15. Now we are at 3 o'clock. Oh, my clock is off a little bit here. So now it's at 3 o'clock. Now let's go back 5 more. So now we've gone back 20. So that's 2:55. That's 25, so now we're at 2:50 and 2:45. Notice it looks like it's almost pointing at the 3. Well, that's because, remember, as the minute hand gets closer to the 12, it's going to get closer to the next hour. So this is actually 2:45, right? 2:45, see the minutes there? 2:45. So a couple of different ways to visualize this and think about how it works on a regular clock and what it's going to look like on a timeline. So we know that he's going to need to start packing by 2:45. Probably p.m. because 2:45 a.m. would be like in the middle of the night, right? We'd still be asleep. All right, let's take a look at 9 groups of 8. Or 8 groups of 9. Whichever one is easier for you to count by, you might want to take the time to maybe count by 9. So let's look at our pattern of 9s. One group of 9 is 9. Then we have 18, 27. Remember, these two digits should add up to 9 when you put them together. 2 and 7 makes a 9 when you put the digits together. We have 36, 45. Now these digits are going to switch places. We have 54, 63, and finally 72. 72 is going to be 8 groups of 9. 1, 2, 3, 4, 5, 6, 7, 8 groups of 9 is 72. Now let's take our 16, and remember, we can use multiplication to figure out what our missing quotient is. This is called the quotient. We can use this factor to help us find our missing quotient. So how many groups of what number can I use to make 16? Well, if I had 2 groups and I want to share these 16 objects equally, then I could start putting objects in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So I have 5 and 3 makes 8, 5 and 3 makes 8. So how many is going to be in each group? 8 objects in each group. And I know that 2 groups of 8 gives me 16. So I can use my missing factor of my multiplication to help me find my quotient. Now we have a simple 1 digit by 1 digit multiplication. We have 2 groups of 5, 2 groups of 5. If I model that, here's a group of 5 and here's a group of 5, and 5 makes 10. So my product is going to be 10. That one was a simple one, right? Now let's take a look at Henry has 3 baskets of apples. There's a basket, there's a basket, and there's a basket. These are called groups, right? Now it says each basket holds 2 apples. So 2 apples in that basket, and this basket, and this basket. This one's pretty simple. How many apples are there in all? So 2 and 2 makes 4, and 2 makes 6. So 3 groups of 2 is going to give me 6. Now, on the back of this, you're going to write your response with, Henry will have 6 apples because if you have 3 groups of 2, you can add 2 plus 2 plus 2, and that will give you 6. Somehow write your response to your thinking. All right, last set, we're going to use our division to help us find a missing factor. So I need to know how many groups of 4 does it take for me to make 24? Or how many groups of this number does it take to make 24? So I can do one of 2 things. I can think about this as counting by force to find out how many groups I have, or I could start taking and putting 24 objects equally, separating this 24 into 4 equal groups. So I could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and finally 24. So I have 4 and 2 make 6, 6, 6, and 6. So my quotient here is 6, but I also know that my missing factor here is going to also be 6. Let's take a look at 49. Divide it equally into 7 groups, or we could count by sevens to see how many is going to be in each group. So I could use this as the number in each group to find out how many groups I have. Because remember, order property says I can switch these, right? So let's take a look at 7 plus 7 is 14, and then 21, 28, 35, 42, and finally 49. So how many groups of 7 did I use to make these total of up to 49? So 1, 2, 3, 4, 5, 6, 7. So 7 groups of 7 is going to give me what I started with in my division equation, which is 49. So my missing factor here is going to be 7. Now let's take a look at this last problem. We have 16, well, what do we have 16 of? 16, let's say crayons. And maybe those 16 crayons are going to get put into boxes. There's 8 crayons in each box. So if there's 8 crayons in each box, I want to know how many boxes I need. So here's a box, and it has 8 crayons in it. So that's 8. And here's a box, and this box has 8 crayons in it. And so now, how many crayons do I have? I have 16 crayons. Well, that's what I'm starting with, is my 16 crayons. So I shared them equally into how many groups? 2 groups. So if I have 8 groups of 2 or 2 groups of 8, because remember, these can be switched, we know that my missing factor here is going to be 2. So this is what I want you guys to do today for your discussion. I want you to take 16 divided by 8 equals 2, and I want you to write a story problem for this equation. Again, take this division equation, 16 divided by 8 equals 2, and I just set an example for you, so that should give you some idea of what you're going to do. That story problem is an example to help you write a story problem for this equation right here. All right, I am going to read these later on today, and I want to be able to share a few with you. So let's see what you guys come up with. Have a great Monday, guys, and I'll see you during our live lessons.